Okay, what we're going to build is this marching robot, which I've decided to call Marching Man. That prints onto the chest that way. The walking mechanism is different. If you go on my Thingiverse thing, you see I post all kinds of different robot walking mechanisms. This particular one, when it walks, it sort of looks like it's doing the military goose step. You know, where they kick their feet up like the Rockettes while they're marching around. What this one is going to do that makes it different is that on the bottom there are just rollers with no ratchets in the heels, and then in the front we just have traction, which are rubber O-rings stretched over printed parts. And at all times both feet are contacting the table, but as you can see in this case, this foot, the toe is in the air, but the heel is on the ground. And that leg goes forward, that can roll on that roller. Once it goes all the way forward, then that foot will go down like this side is, and the toe will then grab, hold the surface. So as this foot rolls back, see how it's going to work, kind of walk and grab. It's kind of hard to describe. It's easier to see. Then there's also a moving piston in the head that goes up and down. And there's a mechanical click-click sound to kind of go along with the marching. The batteries are through this door in the back. It's a lever you open, and a hatch, and it's just a 2 AA battery box, like so. Just fits down like that. Look at that. You got your on-off switch, and there it is, marching along. Got a lot of leg action, a lot of foot action. Isn't going to win any races in distance, but it's moving quite well. Get this closer so you can. It's a very easy build. They're actually very easy parts to print. So let's lay this guy aside and let's get with it. There was only 3 things that you glue in the whole thing. The rest of it is screwed together. Of course, you can do it any way you want. But the first thing is the leg to the foot would need to be glued. And the best stuff I've ever found out there is the 3D gloop for PLA. It just holds a whole lot better. Obviously, if you don't have that, you can use your normal fast set stuff. In this case, I'm going to attach the leg to the foot using a screw, so in case I screw this video up and have to do it again, I won't have the foot permanently already glued on, because I'd like to be able to show that. But before we glue that on, let's go ahead and talk about the inside of the bottom of the foot. This foot prints just like this on your printer, flat, no supports, and when it comes off, there's these places where we're going to stretch little rubber O-rings over to give us traction, and there's a place in the back where we're going to put in a roller wheel. This prints vertically in your bed just as you see it, with no supports. All the parts print with no supports. And as far as coming up with all the different little rubber gaskets and everything, O-rings, you know, the cheapest way to do it is just to buy one of these kits. It's got every size under the sun in it they're like $8 or $9 for the whole kit. You get all these different sizes of O-rings. So if you're into building stuff, spend the $8 or $9, $10, whatever they are in your area, and have that. So, like I say, normally I would suggest that you glue the foot to the leg, but just in case we get interrupted or something goes horribly wrong shooting this video and I have to take this all apart again, I'm just going to screw it on there for now. Like so. So, we'll pretend like you just 3D glooped that baby on there, because then it won't let loose. Okay, as far as the little rubber O-rings, there's one. See that little sucker? See these things? Just see if we can keep this in camera, catch one side and pop it around. Actually, it's easier if you do it from the front to the rear, but I'm trying to hold this thing up to the camera. So you can see it just pop down there. And that'll give you traction for the toe. Very easy to put on. Then the roller wheel in the back, there's places. I'm going to again hold mine on with screws. I have some number 2 self-tapping screws, nothing special. But if you didn't have them, you could use anything you could fit through there through an axle, and you could either bend it or glue it on the outside of the feet. If you had one of those really thick paper clips, that would work. Or if you've got a bunch of these little number 2 tapping screws, which I like to use for my projects, then you can just screw them in either side, and then there's a hole down the center of the roller. I don't know that I can hold this in camera and do it, but I think you guys know what I'm talking about. Basically, the screw screws into the foot, but not into the roller. The roller has a hole in it. Just like so. Then you have that, and you got your grip. So now we have our left and right foot prepped. We'll go ahead and set those aside. Next thing we're going to prep is this is part of the cam linkage for making the piston and the head go up and down. This part prints on your bed just like that, and this part prints in your bed just like that. No supports are needed to print it. These small parts like the gears and these kind of cam things, I print at 0.15, and this piece and this piece are going to be glued together right there to make one tall part. And just in case I have to break this thing apart, I'm going to just put a small drop of glue on there for now. I'm going to give you a picture of what this thing looks like here. So this is what your assembled cam piece should look like. And we're just going to set that aside. We don't need that till later, but it needed to be prepped. So I think we're ready to start assembling. And I'm going to use this standard little motor that I like to use in all the projects. I think the dog wants to go outside. Let me let it out. Sorry about that. We got to take care of our little dog friends. Okay, so we've got to build the main gearbox. There's 3 basic parts of this whole thing. We have a left side, and let's start with that first. And the motor. Most of these motors have a little divot thing, so leave that divot thing sticking away from the frame, obviously, because if you didn't, it would be in the way. And it's set up where you can then run 2 screws in. And again, if you're in America, you would just use a 632 screw, like the ones that you might find in an old light switch or outlet electrical box type thing, or just ones that you might buy. But metric wise, I'm sure you can find something that fits in here, whether it's 3mm or 4mm or whatever. It's basically just going through the frame and screwing into the motor. Again, I can't do this and tell what's on camera and what's not on camera, sorry. If a lot of the video is not helpful, that's because I'm working alone and at a weird angle. I think it might have been better if the camera had been over my right hand shoulder rather than on my left hand shoulder. But I'll show you what we got as soon as we get the two screws in. Right. So, you can see the motor just screws onto the frame. And this is the left hand frame. This would be the front, this will be, pin will be in the back. So, while we're at this point, there's a small motor gear, and it'll fit on there. And it's not even necessary to screw it on, because once the other side's on, it can't go anywhere. But, having said that, I'm already here. I've got screws, so why not just put one in there? It won't hurt anything. So there we go, we have that. Okay, now we have the main center part of the frame. This provides the clicking sound. We'll get to that later. And this whole thing should only really fit together one way. This clicker is going to be to the front and the rest of it goes to the back. And like I say, let me screw this in, then it'll all become clearer when I can hold it in front of the camera so you can actually see what it is I'm doing here. Takes three screws. If you didn't have screws, you could glue these two parts together, as long as you were careful to line the holes up. And I suppose you could always use a paper clip or something to hold the little holes lined up while the glue's setting up. The nice thing about screwing it all together, though, is that you can take it apart to repair things if you break something, or if you want to mod it, or want to change something, or if you start the motor up in the wrong direction. Once we get things going, you'll break this clicker off, and if you break the clicker off, you might want to get in there to re-glue it back on. So this is what we have now. You have the left side bolted to the front middle frame, and inside this middle frame, gotta get back over here, we've got the large gear, and these are the clicker things. The clicker is going to hit on these to make the pattern, where there's going to be a three-way pattern: click, 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 thunk, then a pause, thunk, click, 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 thunk. So it kind of gives it a rhythm. When you're first assembling this, it'd be easier if you put this largest void area towards that little clicker, because then we can line things up to the axle later. So now what we have left is the right side piece, and obviously it's going to go right on top, and it's going to be held on with 3 screws. So let's get that out of the way. If any of you guys that are watching this know of any schools or building, DIY building type places that might be interested in these sorts of projects, be sure to tell them about my YouTube channel and my Thingiverse channel. I'm not monetized. I don't get any money from YouTube. I don't do Patreon. I don't have anybody giving me anything for free. I just do this out of the love I have for mechanics and 3D printing and wanting to share. So it didn't cost you anything. Subscribe, I always like that. It lets me know that somebody's watching and cares. Okay, now we've got this hex shaft, and this little hex shaft prints flat on your bed like that. Again, no supports. And we're going to, this inside of that large gear is set up for a hex shaft. And it's going to slide. As you can see, it slid right in. slid right in. There's a cam, 2 of these that we print. These are the leg cams, and they're set up with a hex, and we're going to put one on each side 180 degrees out of phase with each other. So if this one on this side is back close to this pin, then the one we put on this side we're going to want the opposite way towards the front. If you get these cams on wrong, your robot's going to walk real funny. So you should have something that looks a lot like this. This big area here is where the battery pack sits. Okay. This cam is going to be the cam that moves the piston and hooks up with that linkage that we glued together in the beginning. And it's going to go on this outside part of the shaft. And this little flange or nipple part faces in towards the motor. And just pushes on like that. And again, we don't need to put a screw in it or anything. It'll, once everything's all together, it won't be going anywhere. So, where are we at? Well, I guess I could show you kind of how the legs fit. The legs have a flat side and they have a detailed side. So obviously the flat side, and this is the left leg, the single hole is going to go on the cam. The slot goes on that fixed post in the back. So just fits right on like that. Do the same thing with the one on the other side. There it is. At this point, this mechanism should walk. It could be hard holding power onto the little motor tabs, but I could try. Let's see. I'll find a couple of batteries. We're going to need them anyway. There we go. Now, like I said earlier, you need to make sure your motor is running in the correct direction, otherwise you're going to break that clicker. You'll want this big orange gear that's inside there turning counterclockwise as you're looking at the robot from the left side. And in the 2 of these that I've built so far, that means this positive is towards the front and negatives toward the rear. That doesn't mean you won't find a motor by someone that isn't wired differently, but so far that's what I have found. So I'm just going to try and hold these wires on there just so we can test what we've got going so far. So it was working. You heard the clicking, the legs were going, so everything is good at the moment. What do we want to do next? Well, next, let's take our body. The body prints vertically, just like this. Again, no supports required. Your printer should be able to bridge. Everything is designed with slopes and tapers to print. And let's go ahead and put the arms on. I'm going to just screw the arms on. And again, you could use whatever hardware you've got laying around. If you didn't have screws, you could probably run a little finishing nail or something in there and glue it off on the inside. I didn't really want anything sticking on the inside too far because I didn't want it hanging up on the linkage. If you use a screw, then you can adjust it so you can get a good swinging arm action going as the robot's walking. These arms, by the way, print. I'll come back here, Ron. Print flat on your printer like that. Again, no supports. And being that they were just arms, I printed mine at 0.02. Nothing super fancy, just nice fast prototyping print speed. So there we go, we have our 2 arms. And I don't think there's any reason why I can't put the body on. You can see the body has got mounting holes in the front and the back. So we should be able to just slide this right down. Oh, before we slide that on, I would have to take it off going to want to make sure you have the little piece of linkage on this cam, because it's going to be impossible to put that in if the body was already on. So get your linkage in there. Then you should be able to, using your eyes, just sight down till you see the holes in the gearbox and you go, okay, I'm lined up. Let's put a screw in there so you can see how the body holds the legs on. As long as the legs are held on, then the leg cams can't come off. Everything just kind of holds each other together. So you didn't have to glue any of that stuff, so you can take things apart. And should be 2 screws for the back. So there we go. Everything is in there and hooked on. That's good. On the back, there's a little piece that prints flat. This is your battery latch. And again, I just use another short number 2 screw through the battery latch. It's going to hold the battery door on, and it screws on. There's a raised place on the body for it. You don't want it so tight you can't move it. That's good. The battery door is a separate piece that prints flat like this, and it has a lip on the bottom side, and that lip fits into this trough that prints on the back of the body like that. And then when you slide this down and around, that'll hold the battery door on, keep the batteries in. I'm going to loosen that up a little. Okay. In fact, let's I'm going to take at least one of the batteries out just to make sure we don't short anything out here. And the battery pack, let's slide it in there. I probably should have prepped some of this so we wouldn't have to spend the time to solder, warm up the soldering gun and all that kind of good stuff, but I didn't. Here we go. These battery packs have a flat side. Run the flat side in towards the middle. It's the only way it'll fit in all the way. Take the back thing on. Even though we're going to have to take that off to put the other battery in eventually. Let you know that you're doing okay because it's fit. Okay. We're going to need to have a way to turn it off and on. I like to use these little double pole double throw switches. This very simple little slide switch like you'd find on eBay or something. Nothing special about them really. It's about 19 millimeters from hole to hole. They're inexpensive, so once you find some, just buy a big old bag of them. Because if you ever plan on building anything again, you'll use them. That's why I try to use them on all my projects, so I don't have to keep sourcing out different switches. And there's 2 places on the back for the screws. The switch. And I'm sure my arm's blocking the view, but what are you gonna do? I gotta hold it somehow, right? Okay. So now we have a switch. so we can interrupt the battery. I provided, let's see if it shows up. I can't tell on the view screen, but I think it must be, hopefully, must be visible. This little square thing right here has a hole in it, and the idea is to tuck the battery wires through there. It'll do a couple of things. One, it'll act as a strain relief, so when you slide the battery pack out, you aren't tugging on your solder connections inside the robot. And two, it keeps the wires out of the way of the linkage for the piston up in the head. And both those things are important. The strain release is probably more important, because then when you go to pull that battery pack out, you might tug on it and break some things loose. See how it slides through there? Keeps them out of the way, keeps them down. That way we can route these wires wherever we need them to go. And maybe we're at the point where we need to start doing a little soldering. I'll break out the soldering gun. Soldering pencil in this case. Put that there and there. Like I say, sorry about not having prepped any of this stuff. Because it probably would have saved quite a bit of time if I had done that. I'm cutting a short length of wire to go from the motor to the switch right now, and that way I can just solder the battery box. One, I'm going to solder the black wire, the negative wire from the battery box, directly to the motor, the rear terminal. And I'm going to solder this short length of red wire to the front terminal of the motor and to the switch. And then the red wire from the battery box to the switch. And that way we should be able to put the last battery in there and actually test the locking mechanism before we go any further. First, I'm going to tin these wires up, and I'm going to tin the switch, two of the contacts, the center and then either side, doesn't make any difference. Then, to make things easier, I'm going to tin the two motor contacts. So, again, I apologize for the camera angle not showing you anything, but I think it's kind of self-explanatory. I'm going to try to put the black wire onto the motor. Like so. Let's take the red wire and let's just solder that onto the switch and get it out of the way. Then I can take all that extra battery lead wire and pull it back up, because it'll make it easier to put batteries in if you have as much free wire as possible. There we go. Pull all that extra wire and just pushed it up into the front, out of the way. Let's get that last wire on between the motor and the switch. And maybe, no, it doesn't make any difference. It's just, there's not going to be any way for me to hold this and do it where you can see what's going on. Okay. So I took a wire from the front of the motor, ran it back to the switch, the other wire from the battery pack, the black wire from the battery pack to the rear of the motor. So now, theoretically, we pull this battery pack out, and it does still come out, that's good. And if we put in this battery, and shove this all back together, like so. Other than this piece of linkage rattling around, which might get hung up on something, we should have a walking robot. Very good. So you can see how this piece that goes up and down, that's what's going to drive that piston up in the head. We're getting there. Now the next thing that I like to do is put an LED inside. This is the top of the body. It prints like this, and it's not two pieces hooked together. I simply stopped the print at the neck and switched to black because I wanted it to offset the red piston, which is going to fit in here. And this rod's going to push on that piston to move it up and down. I thought it would look better with a black background, so that's just a filament change. This is one piece, prints flat. This piston is one piece, and it printed with the top down like this. This open bottom slot sticks up in the air. And again, I just did a filament change. I did translucent red, and then about 24 millimeters up, I switched to the black. My thought behind that is once we actually put the head around this whole assembly, this should be in the mouth area, so the mouth should change from glowing red to black, glowing red to black. In order to make this glow, we're going to put an LED in there. Now this rectangular opening is where the push rod goes, and the hole is where the LED is going to go. In this case, you could use any 5 millimeter diameter LED that you might have. This one just happens to be a top hat type. You know, it's kind of blunt and stubby. They're extra bright. Use a red because they have a lower voltage, where they'll turn on sooner. And you're going to want to hold that in place with whatever your favorite kind of glue is. You could hot melt glue it if you wanted. I'm going to use some thick super glue type stuff because that's what's sitting here, and I don't want to have to wait for a hot melt glue gun to warm up. So I guess we could have added that to the earlier prep step, right? Had that prepped. Also, this is going to fit on this way. I ran the wires off to the right, because that way they'll be away from the linkage, because all the linkage is from the left. And we're going to solder wires and a dropping resistor on there. You need to current limit a normal LED like this, and you could do it with any resistor out of something from your junk box or an old board. Anything. This, we have 3 volts. This is a single red, so it'll start illuminating about 1.79 volts thereabouts. So you could go with anything from a 100 ohm resistor to a 220 ohm resistor. It isn't going to make any difference. I found this great big Herkin 150 ohm resistor floating around my junk drawer. So that's what I'm going to put on there. It'll keep from destroying the LED. And I think I'm going to need to trim one of these legs. I don't even know which is positive and negative on the LED yet. We're going to find out. But now let's just solder that resistor on there. Like so. I'm going to need a couple of wires on there. Before I do that, though, I am going to hunt here to see who's positive and who's negative. So in my case, the way I have it set up, negative will go to the resistor. That way I won't get them hooked up backwards. So I'm going to get a couple of different colors of wire. Here's a nice black colored wire, and got some more of this red wire left here. let's just use this. Not quite sure how long we want to make these wires. Actually, they can tuck out of the way because they're over on the right side of the robot, so it doesn't really matter. You can make them nice and long. Like so. Tin those up. I should have stripped the other end of that black wire while I had it in my hands. And let's just solder the red wire on there. Like so. And let's prep that end of the black wire. Okay. So there is our LED, and I suppose it probably would be a good idea if you were doing this, if you had your hot melt glue gun out again, just to secure those wires so there's no chance of anything moving or pulling or anything. Again, since I wasn't thinking ahead and I don't have the hot melt gun glued up, I'm just going to zap it with a little bit of glue here of what's sitting by handy. I would use the 3D glue, except this isn't PLA, this is wire. The glue would stick to this piece, but not to that piece. So we'll just hit it with that and wait a second for that to firm up. And we're going to solder those wires in here. So I'm going to take the black one and go right to that rear motor connection, because that was our negative. Like so. And I'm going to take the red one and just go to the switch. If I go to the battery side, the LED should come on, see, like that, if that's in camera. But I'm going to go to the switched position, so that it only comes on when the robot's turned on. Like so. So at this point, we theoretically should be able to screw this top down. We're going to get this push rod into this rectangular opening, like so. And again, I'm going to turn off the soldering gun before I burn myself. Again, I set it up for screws, and if you didn't have screws, then you could glue it down. But I put 4, one in each corner. And I need to get a few more screws. I just go on eBay when I go for the screws and get them by the bag full. Just get a whole little baggie of different lengths. Since you don't know what you're going to need, if they offer different sizes, they're so inexpensive. Just buy a bag of 100 of various lengths, and whatever project you got going on down the road, you're going to use them. And if you don't use them, so what? You're going to make bigger mistakes than buying some screws you don't use in your lifetime. So don't worry about it, especially something that cheap. It'd be like buying a coffee and spilling it. Not the end of the world. Okay, we're going to get the effect here if things have gone right. Let's find out, because we're just about ready to wrap this thing up. Okay, so now we just take the piston, and we don't have to glue this or anything because it's going to be captive. We've got this slot. I'm just going to slide that over the orange thing. We want the orange thing to ride in that slot. So now if everything works, the leg should move, the LED should come on, and the piston should go up and down. And I would call that a go gird. Okay, we got the clicking happening, we got the piston happening. The last thing you've got is the head shell. And these two pieces I printed in a gold PLA. They both print flat on the bed the way I'm holding them, and they print with no supports. And when they're assembled, they're going to be like that. So let's do a little test fit. Looks like it's going to fit. And again, this would be a perfect thing to use the 3D gloop for. But again, if I screw this up and have to shoot this video again, I'm going to want to be able to get that apart. So, because the 3D gloop is great stuff, but it's permanent stuff. So I think we're going to go semi-permanent here. So one thing I've always found out about super glues, if you use them, is you can chip them apart again. You can go at them with a razor blade and get right on the seam. And you can almost always pop the part off again without breaking or damaging too much anything else. So that's handy. Put a little spritz on there and then try to line it up right the first time around. By golly. Let's see if the head effect works. Alright, you got a moving piston and a mouth that goes from black to red. We got a marching robot doing the goose step. We got a nice rhythmic clicking action. And you see it's an easy build. Even easier if you're not trying to film it at the same time. Doesn't really cost you anything to build it. I mean, the little motor that we're using in there, they're $1. You can get them even less than $1. Of course, you can pay more, but they're very inexpensive. The battery holder almost costs more than the motor. An LED you can probably find out of something. You don't have to buy an LED. Plastic could be any plastic. I mean, the first one that I did was all in just white because I had some white I wanted to get rid of. So that was the prototype one. This one I thought it'd be kind of cool to do it in some colors. That's why I went with black feet, white legs, orange hands. This is silky blue. This is silky gold. So there you have it. Marching Man. Build one. Have fun. Subscribe to my YouTube channel. It's the only feedback I get. It makes me feel good if you enjoy the stuff I'm doing. Again, if you know of any schools or classes that are looking for projects for the kids to build and learn, turn them onto this stuff because I think it'd be perfect for learning 3D printing, mechanical principles, electrical, very simple electrical things. Anyway, thanks a lot. Have fun.